Hello, structure students. This is a fairly short video on a topic that we've had before in statics, centroids, how to find the centroid of a complex shape. So I'm going to start with a pretty simple shape, but then it just applies to whatever kind of shape we have, whether that's a W shape or a C shape or a shape like I'm going to do, which is a standard rectangle. So kind of a review on centroids. We'll need it when we get into beams and columns, which we will move into fairly soon in structures. So, all right, if you'll remember the formula, summation of, that's my summation sign, areas, y distances, and then the total area. So here's our shape. We're not focusing very well, so there we go. We have a 2-inch diameter hole, and then we have an 8x4 rectangle. So remember that you're going to break these areas up into numbers or letters, whatever you want to do. My hole is going to be area 1, and my rectangle is going to be area 2. And you treat those individually, so you have to know where their y bars are. So for the rectangle, y2 is going to be 4 inches, half of the 8. And then this 2 inches is going to be my y1. If this is shape 1, then this is y1. And those are distances to the centroid. So once you have that, you need to figure out your areas. So I know my area 1 here is going to be pi r squared. So that's going to be pi 1 squared. So area 1 is going to be 3.14 inches squared. Okay. And then you need area 2. Area 2 is here. And that's just 8x4. So what's that? 32? So hopefully I don't muck up any math here. All right, once you have those areas and y distances, then you can fill in your formula. Remember that holes you subtract and solids you're going to add. So y bar in this case is going to be area 1, that's my 3.14, times y1, 2 inches, minus, oh, that's a negative, right? So that's a negative. And then plus my solid, which is 32 inches squared, times its y distance, which is 4. And then all of that is over the total area A. So that's the addition of the two. I'll put in the positive one first, and then subtract the whole. And hopefully we're charged up here. I have 3.14. That's negative. All right, problem with this online stuff is I don't have anyone to check my calculations, so you all should do that. Wow, you can't see the calculator. It's on, but it must be at the same frequency as the camera. Oh, there it is. Oh, I have to hold it at just the right angle. Ah, there it is, just the right angle. That's weird. All right, well, we'll have to work our way through that. 4.217 or 4.22. And that makes sense because we have more mass up here. And we have less mass down here because of the subtracted whole, so it's going to shift up. Where the rectangle by itself has a y-bar of 4, but when we cut the hole, the y-bar now is 4.22. So why do we need that? Because when we go to inertia, we need to know where that composite centroid is, or that composite y-bar. So here is y-bar. And that'll be what we do next, is a review of the inertias. But for now, we'll just stay with this. So good luck on your homework. I didn't choose difficult ones, but I believe I did choose ones that have structural shapes. So you may want to remember how to do all that. The nice thing about structural shapes is you do not have to calculate the areas. You look those up, but you do have to locate the centroids. So find those centroids and those individual centroids, and then put them into the equation and see what we get. All right. Nice job. Take care of yourself.